Good morning. I hope everybody is having a good Wednesday so far, good E-Day. And so we're going to cover a new topic today. So it's really important that you watch the full video and take notes in your 3-ring binder. We will not go over this tomorrow in detail, so it's really important that you get all of your details from the video today. We are graphing quadratic equations. So we've been dealing with quadratics up to this point. We have solved them, right? We have factored them. We have solved them. We have, when we solved them, remember that's the same as saying finding the x's or finding the zeros, where the quadratic goes through the x-axis. I told you that we would later be graphing quadratics, and that is what we are starting now. So first of all, let's talk about what a quadratic equation is. You guys are familiar with what it should look like based on the last couple indicators we've been doing. So a quadratic is ax squared plus bx plus c. And we have been, this is a quadratic expression. Now we have been setting it equal to 0 in order to factor it, and that's fine, right? That's perfectly legit. We've been plugging a 0 in for the y because we've been factoring it and then solving it to know where the quadratic goes through the x-axis. We're going to kind of look at it in a little bit different way in this indicator. We're going to put the equal, or we're going to put the y. Remember, this stands in for the y, right? We've talked about that. The reason we plug a 0 in for the y is because when we plug a 0 in for the y, that gives us the x-intercepts, and that's how we solve it, or solve where the x's or where the quadratic crosses the x-axis. That's what it means to solve a quadratic. Now we're going to look at it a little bit different. We're going to put the y on the other side, and it doesn't change anything. So y equals ax squared plus bx plus c. You can see that the quadratic equation is still the exact same. The a, the b, and the c are still just numbers, and then the x squared and the x are in the same order. Okay, so we've just flipped the y to the left instead of having it on the right. Doesn't change anything. So what does a quadratic look like when it's graphed? Well, a quadratic makes a U shape. So on a coordinate plane, we have an x and a y axis, and that's why we have in our equation here, right? We have x's and y's, and those x's and y stand for all the xy coordinates, right? All the xy coordinates, the points that plot along this graph. So let's see, we can have them open up, which when they open up, they look something like that. Okay, that is a quadratic graph. When they open down, they look something like this. Okay, and they can be anywhere on the coordinate plane. And so we're going to deal with some that open up and some that open down. A couple of terms that we're going to talk about here is we're going to talk about the vertex. The vertex is just either the far low or the far high of the quadratic, right? It's the very low of the low, or it's the very tip top if it's a quadratic that opens upside down. So the vertex is just simply either the highest or the lowest, depending on if it opens up or down, point of the quadratic. Okay. The other thing we're going to talk about is an axis of symmetry. Now, that's a really, really fancy name for a line that runs right down the middle of the graph. So on the red one, that would be the axis of symmetry. Symmetry means the same on both sides. So axis of symmetry just means it's a line that runs right down the middle, and on both sides, it kind of mirrors each other. Okay. Fancy term, very basic concept. Again, on the blue one, if we were to draw our axis of symmetry, it just goes right down the middle of the quadratic and splits the quadratic in half, and it's a mirror image on both sides. So this will come in handy when we're graphing this, because to graph a quadratic, you need 3 points. One of those points is always going to be your vertex, right? That's always going to be a point. And then we're going to pick another point on either the left or the right. And the nice thing about the axis of symmetry is that if we graph a point, say, on this side of the quadratic, let's say it's here, okay, then we will graph a mirrored point exactly on the other side at that same level. So the really nice thing about axis of symmetry is that you only have to find the vertex, and then you have to find one other point, and then using the mirrored effect of the axis of symmetry, your third point basically plots itself. So it makes it really nice. All right, so we've thrown out a couple terms here. First of all, let's talk about how I said the most important point was the vertex. So remember, the vertex, again, right, is a point, so it has an x and a y value because it's a point on a coordinate plane. And so we need to be able to find the vertex. And so to find the vertex, we need a formula. And that formula is x equals negative b over 2a. And we should be very familiar with finding the b, the a, even the c, because we did that in indicator 23, where you had a equals, b equals, and c equals, and you needed those to plug into the quadratic formula. Well, same thing. We need to know what the b equals. We need to know what the a equals, because we're going to plug it into this formula to find the x. Now, keep in mind, when we do that on the vertex, right, we've already talked about the vertex is an x and a y, right? Well, when we plug into this equation and we find the x, right, that just gives us the x of the vertex. So I'm going to talk about here in a minute how you find the y of the vertex, and basically once you find the x, you just plug it into the equation and then you get the y. So, and we've done plug and chug before. We know how to, if you have two unknowns in an equation, if you know one, you can plug that in to find the other one. And so that's not anything new. We're just going to be utilizing that skill here in this indicator. The other thing is, we've already talked about it, but I'll write it out just so that you have it. But the axis of symmetry, and I'm going to abbreviate here, the axis of symmetry is just a line, right, that runs down the center of your quadratic. And since it runs down the center, and we've already talked about it, that your vertex is right in the center of your quadratic, because the vertex is that mirrored point where your quadratic turns around and goes the other way, the axis of symmetry always is going to run through your x, right? Because it's going to run up and down right through the x. So the line that runs down the center of your quadratic through the vertex, specifically through the x value of your vertex. Okay? So that's a little bit of terminology, just a little bit of intro into quadratics. And so now we're going to practice graphing them. So I'm going to go back up here, and we're going to look at this first example. So if you're watching this on the video, I would pause it for a second and write down this quadratic equation, and then also sketch a little graph that looks similar to what's on my screen. All right, so hopefully you've done that. You've unpaused it. Now you've got this in your notes. Let's talk about what we had to need to do. So first of all, I'm going to identify what A equals, what B equals, and what C equals. You've done this before, right? You did this when we were using the quadratic formula. So A equals, well, it's not there, but it's there. It's a 1. B equals this center number, which is -2, and C equals -3. Okay? So the first thing we have to do is we have to find, and you're going to do this with every single quadratic you've graphed, the first thing we're going to do is we are going to find the vertex. And keep in mind, the vertex is an x and a y point. Okay? So we know the formula for vertex is x equals -b over 2a. So to find the x part of the vertex, we're going to use this formula. So let's plug in what we know. Well, the formula says -b, and our b here, right here, is -2, over 2 times a, and our a value there is 1. So we're going to plug that in. Well, -2 is positive, and 2 times 1 is 2, and that reduces to a 1. So the x, remember, this is the x value. This is the x of our vertex. So where our vertex coordinate is waiting to be filled in, we're going to fill in a 1 for the x value. Well, now we need to find the y that goes with it, right? So in order to do that, we would plug into our equation. Well, here's our equation right here, right? This is what we're going to use. So we're going to say y equals, now I'm going to put a parenthesis where there was an x. So x squared minus 2 times x minus 3. That's our quadratic from up here, right? X squared minus 2x minus 3. But now I know that the value of the x of the vertex is a 1, so I'm going to plug a 1 in here. And now you have to use PEMDAS, right? Parentheses, exponents, multiplication, division, addition, and subtraction last. So PEMDAS matters here, and don't have anything inside the parentheses to simplify, so I'm going to go ahead and do the power, which 1 squared is 1. Now I'm going to do the multiplication. Negative 2 times 1 is negative 2, and then that negative 3 I haven't dealt with yet. Now I just have a long string of addition and subtraction. So left to right, 1 minus 2 is negative 1 minus 3 is negative 4. So the y value, remember this is the y value of my vertex. So now up here in my vertex, I'm going to put the y value of my vertex. So all of this work so far has just been to find the vertex. And now I'm going to graph my vertex at 1, negative 4. So 1, negative 4. All right, there we go. That's our vertex. That's the first point you always want to plot. Now we need, first of all, we're going to draw in our axis of symmetry, and we've already talked about what that is. That's just this straight dotted line that runs. It's an imaginary line, right? That's why we dot it. It's an imaginary line that runs up and down right through the middle of our quadratic. So it runs right through that vertex, and we know that that serves as a mirror point. And here in a second, I'll show you where that comes in. All right. Now we need a second point, right? I said you need to find the vertex, then you need to find a second point. So our second point, okay, or we'll just call this point number 2, right? Point number, oh, that's terrible handwriting there. Let's try that again. All right, we're looking for point number 2. And again, a point is an x and a y. We know that it is an x and a y. So we're going to pick another x. Now, the vertex x we had to find by using the vertex formula. This second point, this is up to you, right? You get to choose. So not everybody is going to pick the same second point, and that's okay. What you want to do is you want to choose a point to the left or to the right of your axis of symmetry that's going to be easy to use. So in this case, the axis of symmetry is right there at x equals 1. So I'm going to pick an x value on either side of that that's easy to use. So for me, a 0 is really, really easy to use. I'll show you why it's easy to use. But the 0 is really close. So I'm going to pick 0 for my extra x, or my extra point. And that's just the x I'm picking. I still have to find the y. Well, how do you find a y when you know the x? Same thing we did before. We've got y equals x squared minus 2 times x minus 3. We're going to use the same equation, and we're going to plug in our x that we picked for our second point. Now, the reason I picked 0, and you'll see why if it works, it's great, is when I plug a 0 here and a 0 here, 0 squared is 0, negative 2 times 0 is 0, so you get y equals negative 3. Right? It's really, really nice to use 0 when it works. Now, what do I mean by when it works? Well, you'll notice that when I plug in a 0 for x, the first two terms go away, and all I'm left with is c, right? Notice over here, our c was negative 3. So when you plug a 0 in for x in a quadratic equation, your y value is always going to be c. Well, if you look at your graph, do you have the c value on your graph? Can you see that c equals negative 3 on your graph? Or, sorry, can you see that y equals negative 3 on your graph? Well, on the y-axis, which is right here, all right, this is your y-axis right here, negative 3 is right there. So, yes, we can see the y equals negative 3. So the reason that is important, I'll show you on one of these other graphs, when the y is off the chart, you can't use it. You can't use 0, but when the y is, when the c value is on the chart, you can use 0. That'll make more sense in this next example. But for my second point, I picked a 0 for x. I plugged it in. I got negative 3 for y. Now I have a second point I can plot, right? This right here is my second point. So on my graph, I'm going to go and I'm going to plot the point 0, negative 3. Well, 0 on the x-axis is right here on the 0, or right here, and then negative 3 is right here. So there is my second point that I found plotted. Here's where the nice mirror thing comes in, okay? If you look at your point, how far is it away from your axis of symmetry? Well, on your graph here, it's 2 blocks away. So if we go 2 blocks to this side, we can graph our mirrored point. That's what I mean by that whole axis of symmetry thing makes your third point super simple. You have to have 3 points. The vertex, got to do a little bit of work to find. Point number 2, got to do a little bit of work to find. Point number 3, super simple. Reflect it across the axis, the exact number of spots, left to right, and boom, you've got your third point. And now with 3 points, you can graph a quadratic. Now, people, and I'm going to put this and then I'm going to delete it. People get in the habit of graphing this like this. Quadratics are not V's, okay? Do not graph a quadratic as a V. A V is an absolute value graph, not a quadratic. So you want to make sure and give it some softness or a U shape at the end, right? So it's going to go like this. Oops. It's going to come down. It's going to hit the vertex, round, and go back up. Now, do I expect these to be perfect? No. Am I an artist? No. But try to give it some sort of rounded shape there at the bottom, okay? Quadratics do not go, I'll show you here, I'll just use this graph to show you. They do not do this, okay? They're not a V. They also do not do this. Now, if you see the difference between the two I said don't do, right? These are the don't do's. They're not a V, and they do not turn and go straight up on both left and right. You can see here they angle and get wider and wider and wider. That's what quadratics do. They come down, they take a soft turn, they go back up, and on the left and the right, they gently angle wider and wider and wider. Okay, so that's relatively, like I said, do I expect you to be an artist? No, but try to get used to rounding the bottom and then letting your left and right arrows kind of angle out. Okay? All right, I know that's a lot of work. I promise once you do it a couple of times, it does go smoother. It does get kind of easier to do. So let's run through another example. All right, so again, if you're at home, pause the video, write this equation down, sketch the graph, and then we'll get rolling, okay? All right, so first things first. Always, 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 what you want to do is you want to identify your A equals, your B equals, and your C equals, okay? We're used to doing this, so we're just going to keep rolling with it. Here, our A equals a -2. Okay, and we're not used to seeing a negative out front, but that's okay. I'll show you what it means. Our B is 16, and our C is -31, and that's a really high C, and so I'll show you what I mean by that being off the graph here in a second. So what does it mean when your A is negative? Well, if you'll notice in our first one we graphed, our A was +1, and our graph opened up. You'll see here in a second that when A is negative, that's going to be when your graph opens upside down. Okay, so, and we'll see how that works out here in just a second when we do it. So first things first, right? As always, we are going to find our vertex. And the vertex is a point. It's an X and a Y coordinate. And to find the X of our vertex, we're going to use the -b over 2a. So -b over 2a. All right, so b is 16, over 2 times a is -2. Okay, so let's simplify this up a little bit. -16 over 2 times -2 is -4. Our -16 divided by -4 is +4. That is the X value of our vertex. Now we're going to take our quadratic and we're going to say y equals -2 times x squared plus x, times 16x. So -2x squared plus 16 times x minus 31. Now these numbers get really, really big, but I promise you they very quickly get really, really small. Okay, so don't let the bigger numbers mess you up at first. Now, what are we plugging in for the x? Well, remember the x of our vertex is right here. So everywhere where there was an x in our equation, we are going to plug in a 4. Okay, -2x squared plus 16x minus 31. Now, this is where I say PEMDAS really, really, really matters, okay? Do not take negative 2 times 4 first, because there is a power that has to be dealt with before you can take any multiplication. So remember, exponents before multiplication. So I'm just going to leave this negative 2 here. And now I'm going to apply the exponent first. 4 squared, 4 times 4 is 16, plus 16 times 4 minus 31. All right, now I'm going to do my multiplication. So negative 2 times 16 is negative 32. 16 times 4 is 64, so plus 64. Your signs are going to matter so much in this. Do not forget about the whole multiplying and dividing negatives, okay? It's really going to matter. And then this minus 31 I haven't done anything with, so I'm just going to drop it down. And again, all I'm left with now is a long string of addition and subtraction. So negative 32 plus 64 minus 31 equals, and again, remember I told you the numbers get really, really big, and remember this is all y equals. The numbers get really, really big, then they get really, really small. If you end up with a vertex, let me plug that vertex in, right? So this was y equals 1. We're going to plug that in to the vertex. Now I have a point for my vertex. If you end up here with like a y equals 120, you've done something wrong, okay? Because you're not going to end up with y's that big because you can't graph them on your graph. That's way off your graph. So if your big numbers don't go down really, really quick to small numbers, you've done something wrong with your signs, and you just need to look at your signs. All right, so now we have a vertex, right? Right here. This is my vertex. I'm going to plot my vertex. 4, 1. That's a point. 4, 1 right here. And this is where I say if you end up with a y value of like 100, right, you can't plot the point 4, 100 on this graph. So you've done something wrong on your signs. All right, now we need a second point. Okay, right? Our second point. Oh, let's do that in black. All right, we need point number 2, and it's an x and a y. Now, here's where I was talking about earlier. If I try to use, and I'm going to try it, and then I'm going to show you it doesn't work, and then I'll erase it. If I try to use 0 for my x here, well, when that goes to 0 and that goes to 0, I'm left with negative 31, right? And that is a point on this graph. It is a point on the quadratic. It's a valid point. However, it is way off my graph. My y's only go down to negative 8. So if I try to plot the point 0, negative 31, I'm like way down here, like way, way, way down here. That is way off my graph. So when your C value is off your graph as far as the y-axis, you're going to have to kind of back up a little bit and not try to use that 0. So I cannot use 0 for my x here. If it works, great, but it's way off my graph. So I'm going to pick something closer to my, what haven't I drawn yet, my axis of symmetry. So I'm going to drop my axis of symmetry in here. And remember I said you want to pick an x value close to your axis of symmetry. Well, my axis of symmetry goes through there at 4, so I'm going to pick a 3, right? Or you could pick a 5. It doesn't matter which side. You could pick 2 or 6, right? Those are kind of close. But you really don't want to get much further away from your axis of symmetry, because you saw what happened when I tried to pick 0. I ended up way down here off my graph. So you want to pick something closer to your axis of symmetry. So I'm going to pick a positive 3 for my x, right? Now I'm going to do the same thing that I did right here on this step, right? And I'm going to have to scoot down to do it because I'm kind of out of room. But I'm going to take my equation. So y equals negative 2 times x squared plus 16x minus 31. That's my equation. And now, since my second point, I've chosen a 3, I'm going to plug a 3 in everywhere there was an x. Now, Pemdas, right, please remember, I'm going to do my power first. So negative 2, 3 squared is 9. It's not 3 times 2, right? It's 3 squared, so 3 times 3. Plus 16 times 3 minus 31. Now I'm going to do my multiplication step. So negative 2 times 9 is negative 18. 16 times 3 is positive 48, and then minus 31. And now I just have Now I just have a nice long string of addition and subtraction. Negative 18 plus 48 minus 31 equals -1. Again, right? Big numbers blow up big. Everything melts down really small. It always should on these. So this is my second point y. So I'm going to come up here, right, to where my second point was, and I'm going to put in that y value. Now, 3, -1. That is my second point. So I'm going to come up here to my graph, and I'm going to, just for now, I'm going to erase these because I was just pointing to show you what I was looking at. I'm going to graph the point 3, -1. So 3, -1. Okay. Now, because of my axis of symmetry rule, I am 1 block away from the axis of symmetry on the left. I'm going to go 1 block on the right. Now I've got my 3 points, and I'm going to graph my quadratic. It's going to keep going and going and going and going and going this way. And if you'll notice right now, this is obviously not to scale, but if you were to carry this all the way down to -31, right, on the x or on the y-axis, eventually, well, if this was drawn better, you would eventually come down, 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 and you would hit that 31, but it is just way off the graph. So that's why you couldn't use the 31 in this case, okay? So find your vertex, plot it, draw your axis of symmetry, pick a second point, x value, close to your axis, plug it into your equation to find the y, and once you find the y, you can plug it back in, have a second point, plot that second point, mirror for your third point, and then draw your quadratic. Okay, I know it's a lot of steps. These are very time consuming, which is why your assignment only is going to have 4 of these to do. So when you're done with this video, go ahead and click load on the assignment tab, and you will have 4 quadratic equations to graph for your homework tonight. And those need to be done and ready to go for class tomorrow so that we can move on to the next part of Indicator 25 tomorrow. If you have any questions, please feel free to email me. And this afternoon at 1:30, I'm going to open up a Zoom call for any, or not a Zoom, sorry, that was last year, Google Meet. I'm going to open up a Google Meet at 1:30 today that will be open until 3 for you to come in anytime between 1:30 and 3 and ask any questions you might have about your homework or clarify anything about the notes that you didn't understand. So email me if you have any questions. Jump on the Google Meet at 1:30 if you have any questions. Otherwise, I will see you tomorrow in class.